A uniform rope of length L lying on a frictionless horizontal surface is pulled at one end by a force of F. What is the tension in the rope at a distance of L by 4 from the end where the force is applied? So uniform, length L, lying frictionless, pulled at one end with a force of F. Okay, so those are the key things. So question is asking us to figure out, say I have a surface. I have a surface and I have a rope. I have a surface, I have a rope, and I have a force of F over here. And this is uniform rope, means the mass is, or it's not massless, so the mass is evenly distributed. So any point of any part over here has the same density throughout. Basically, the density is uniform. Okay, so what we are looking at is somewhere along the 1/4 length. Say this is looks like half, and this is, yeah. At this point, there is a tension, of course. This is the tension force and all of that. So we have to figure out the tension force at that point over here. At here, we need to figure out the tension. I'll call it as Tx, where x is L by 4. So I'll give you guys a clue on how to solve this, and you guys have to solve it. You have done this before actually. If you want to pause and think over, please do. So what I can do is I can replace this entire setup with two blocks, and I can call this as 3m, and I'm calling this as m, and that is your force of F. So what I'm doing here is, let me start the working, or let the mass of the rope be 4m. So from point A to B, and say this is C, from A to B, the mass will be 1/4 of 4m, that is m, and from B to C, the mass will be, this will be how much, guys? This will be 3m. 4m minus m will be 3m. Okay, so I kind of got confused. So 3/4 of 4m, and this will give us 3m. Perfect. And that I'm converting it into a, this values, I'm converting this into a set of blocks. So what we have to figure out is tension at this, between these two. So from, this is the working. T1's or Tx's perspective. This is Tx, by the way. Before that, I forgot. We need to figure out the system's values. That is system's mass. It is 4m. System's acceleration. That is what we have to figure out. System's force, or force on the system, is equal to F. And so the system will accelerate at so system acceleration of the system is F by 4m. That's it. So now we know that this entire thing is moving at a pace of, or getting accelerated at the rate of f by 4m. We'll be able to figure out from t-axis perspective. So what we have here is tx is equal to mass into acceleration. So mass is 3m itself. Acceleration is f by 4m. So this in this gets cancelled. So you have the tension to be 3/4 of f. It's commonsensical, but still, this is how you calculate. So you got the funda, right? So here two things has to be, taken as something that you guys are learning new. One is how to convert such complicated question into the one which you can already solve. And next is, well, actually that's it. If you're able to figure this out, you are pretty much done. And next is, yeah, this is common sense. This is a commonsensical answer. It has to be. If this is 1/4 and this is 3/4, and you're applying a force of F, so the force F, 1/4 of the force F will be used between A and B, and 3/4 will be used between B and C.